Hello and welcome to a video on the triangle inequality theorem. So what we're going to talk about here is this question in front of you right now, and that is, given we know that every triangle has three sides, that's what a triangle is, but the question is, can a triangle be formed by any three sides, or are there rules that control that? So I gave a couple of sets of sides, and I think if you look at these three sides, A, B, and C in red, you can imagine a triangle being formed by them. And if you look at the three sides in purple, you can imagine a sort of an equilateral triangle being formed by them. But what if we had a triangle with these three sides here in blue? What if we tried to draw a triangle based on those three sides? Well, we would have the longest side, something like this. And then if we tried, and that would be our side A, right? And then if we tried to put side B and C, like they're really short, right? So if we put something like that, and I'm just estimating, but if that were B and over here were C, it doesn't really matter how I angle them. It's just not going to work, right? You're not going to get those two sides to connect to complete the triangle. So the answer to the question up here is no. You can't form a triangle based on any three sides. There are certain rules that control this, and that's what this lesson is about. What exactly controls that? So here's a triangle that has two sides, the two smaller sides here, 18.2 and 24.2, and then the longer side, 32. And up here, it's telling you that the sum of 18 and 24, 18.2 and 24.2, is 42.4. Now, what happens if we manipulate this triangle and we try to make, let's say, the shortest, most obtuse possible triangle that we can possibly get? And I'm getting really close to it right here. Now, this is still a triangle. It's a really, really flat triangle. And I can even move this up here so it's on top. Maybe I can't. It's a really flat triangle. In fact, I can't move it any closer. But look at the sum. 13.3, 23.8 equals 37.1. That 37.1 is greater than the 36.9. And as I stretch this point C down, that difference gets even larger. As this becomes more and more of a taller triangle, or however you want to think of it, this 53, the sum of the two smaller sides, becomes even more greater than the largest side of the triangle. All right? If I make the largest side of the triangle even larger, it doesn't change that. It doesn't change that fact, right? Now the longest side of the triangle is 49.3, and the sum of the other two is way more than 49.3. And when I flatten this out, and when I get it as flat as I can possibly get it, it's still greater than 49.3. In fact, if it's going to be a triangle, the sum of the smaller two pieces has to be greater than the larger piece, or the larger side. So if we look at the three examples that I had set up here, you can imagine that adding B and C, you're going to get something longer than side A being the longer side. Here, B and C, well, they're all pretty much equal. So you can pick any one of these and call it the longest side, but for sure the other two add up to more than that. But in this case, the longest side is A, and the two smaller sides will not add up to A. And they can't be equal to A, by the way, because if they were exactly equal to A, then these two sides over here, they would just lie flat. They wouldn't quite make it. So for example, here, let me draw that out. So if you imagine now, here you have the longer side. Now I'm not going to measure this out because it's hard, it's just as easy to see this way, but if you imagine these two adding up to exactly the purple, so if A and B exactly added up to C, then it would look something like this, only it would just go a little bit farther, where A might go a little bit right up to B, but it wouldn't have any place to go. Like it wouldn't make a triangle, it would just make a line right on top of another line. All right, so let's look at this as a rule here. So what we're saying, again, let me just say this one more time, is that the two smaller sides have to add up to more than the longest side. So in our notes, this is called the triangle inequality theorem. And for any three segments to form a triangle, the longest side has to be shorter than the sum of the other two sides. The longest side must be less than the sum of the other two sides. Okay? So we can put this into practice, and we can now look at some lengths, and we can just make a quick decision. So we would always compare the longest side, and that's, in this case it's 10. So we say 10 has to be less than 5 plus 7, and it is. So therefore this one does make a triangle. Okay? We can do the same thing with any of these. So here, for part B, 21 is the biggest. So the question is 21 less than 15 plus 6? And the answer is no. It's not less than. It's equal to. So it's got to be less than. So this is a no. All right? Here we'd say, well, 1 is the biggest, right? So is 1 less than 1/2 plus 1/3? I know you probably don't love fractions, but if you add a half and a third, you get less than a whole. So 1 is more than. So this is another no. For this one, you really can't tell by looking at them in this form. You really need a calculator. So I'm going to I know that rad 7 is the biggest one. And I know that the other two are smaller. I just don't know what they add up to unless I get a calculator and see. So when I put these in a calculator, I see that rad 7 is about 2.6. And I see that rad 5 is about 2.2. And I see that rad 6, I don't know why I put rad 3 there. This should be rad 6. I see that rad 6 is about 2.4. And now I can say, yeah, 2.6 is less than the sum of these two. 2.6 looks like it's equal. I mean, of course, it doesn't look like it's equal because these add up to something like 4.6. And 4.6 is definitely more than 2.6. So this is definitely a triangle. As long as the radical of the biggest one, in this case the biggest length, is less than the sum of the other two, then you have a triangle. All right? Now, there's another way to say this. Another way to say the same thing is that each side of a triangle must be less than the sum between the other two sides. Let me say that again. Yeah, so another way to say that is that each side of a triangle must be less than the sum of the other two sides and greater than the difference. And that's what I have right here. I just don't have the inequalities. So any side must be greater than the difference between the other two sides and less than their sum. So let's look at that and see what exactly does that mean. I know it gets a little confusing at this, but let's first fill this out. So another way to say this is each side of any triangle must be less than the sum between the other two sides and greater than their difference. In other words, here, one way is here. This is the part that says it's less than the sum, and this is the part that says it's greater than the difference. For a moment, just don't worry about those absolute values. So if we are looking at two sides of a triangle, right now we don't know what the third side is. So we don't know whether this 11 might be the biggest side of the triangle, but it might not be. We don't know until we know the third side. But what we can say is that the third side will be between the sum, so it's going to be less than, let's call this the third side, will be less than 11 plus 7, or less than 18. Okay, the third side has to be less than 18, and also it's true that the third side must be greater than their difference. So the difference between 7 and 11, 11 minus 7, or greater than 4. Now we have a couple of possibilities. We have anything, if we have a third side, let's say that it equaled 18. Let's say the third side equaled 18. Then you'd have 7, 11, and 18. And 7 plus 11 is equal to 18. 18 is not less than 7 plus 11. It's equal to. So that would be like the case where I showed you down here where the triangles lay flat on top of each other. It would be like 7, 11, and 18. No triangle there, right? So 18 is not an option, right? So let's come up here and look at these numbers again. 18 will not make a triangle. It's got to be less than 18. Let's say it was 17.9. Now we have a case where we have 11, we have a 7, an 11, and a 17.9. Now you've got 17, so we're asking the question, is 17.9 less than the sum 18? And that's a yes. So 17.9 is okay, 18 is not. It has to be less than the sum. On the other side of this same idea, if you were looking at the difference between the two, let's say we had 4. Well, 4 won't work either, because then your three numbers would be 4, 7, and 11. And 4, 7, and 11 doesn't work because 11 is not less than 4 plus 7. And looking down here at the picture that we had before, that would be a case like this whole thing were 11, and this were 4, and this were 7. It just doesn't, it's not big enough. The two smaller sides are not big enough to form a triangle. They're just going to lay flat. They have to add up to something a little bit more to make any triangle at all. Okay. So I'm going to lay these out, and I'm just going to show you how simple it is because it's kind of hard to explain. I think hopefully you see it, but the process is very easy. So we want the third side. Let's just say, let C equal the third side. Then all you have to do is say that C is less than the sum of the two numbers that you're given and greater than the difference, 11 minus 7. That's it. The only reason the absolute values are there is so you could say 11 minus 7 or 7 minus 11. If you put 7 minus 11 in absolute value, it's the same thing as 11 minus 7. Think about it for a second, right? That would be absolute value of negative 4, which is 4, and that's 4. So that's the only reason the absolute values are there. It's not to confuse you, it's just to make sure you put these in the right order, or else you make up for it by taking the positive difference. This says that C must be greater than 4 and less than 18. So that would be our answer. C is greater than 4, less than 18. Something that can easily get lost on students because it's kind of hard to understand, but once you do it a few times and you think about some of the numbers, it will make a lot more sense. All right, now there's another relationship here that's pretty interesting, and this is another inequality. So in any triangle, the longest side will always be across from the largest angle. So opposite or across from the largest angle. I'm just going to put across from the largest angle. The shortest side will always be across from the smallest angle. Okay? And it works the other way around too. In any triangle, the largest angle, well, I mean, they kind of say the same thing, except they're really kind of converses of each other too. So we're still going to say it. We're just going to write it out pretty much with the opposite here. Okay, so you're probably going to see these both as saying the same thing, and that's okay. All right, so when we look at a triangle, here's a triangle, and we know all three sides of this triangle. And since this is the largest side, across from that, that's supposed to be an R, that's the largest angle. So this would be the largest. And this is the medium side, so I'm going to say that's the medium angle. And this is the smallest side, so across from that would be the smallest angle. So if we want to write the angles from smallest to largest, the smallest one would be angle Q. The medium one would be angle P. And the largest one would be angle R. The same thing applies for the angles here. So across from the largest angle is the largest side. That would be the largest side. This would be the medium. This would be the smallest. So the shortest side would be IG. There's IG, and then there's the sides from shortest to longest. Okay, that's triangle inequality.